So, first of all, Jonathan, thank you for that wonderful introduction, too generous, and to the Center for Medicine, Health, and Society. Let's get rid of this. Here at Vanderbilt for sponsoring this talk, and to Lynn, who's even now outside, probably getting that keg organized for her organization of my travels, et cetera. It's really lovely to be here. I think this is the right computer. Let me also say I want to start twice in this paper. The first is I want you to read a rather long quote, and I want you to look at the parts that especially are bolded. This is from Miguel Nicolelis, who is I guess I want to call him a public intellectual, a neuroscientist who has a fabulous website, does amazing work at Duke, and has written many popular books, been on TV, on radio, trying to explain what it is neuroscientists do when they study the brain. And he says on a radio interview, "The greatest dogma of neuroscience for the last 100 years has been the belief that particular parts of the brain were very highly specialized for a particular function. That's not quite what goes on. There's more of a neuronal democracy. Neurons all over the brain are voting, albeit in different ways, to perform a particular behavior, to generate a particular behavior. That's what the brain does. The brain is about the future. It plans the future of our motion, and during that window, a half a second or so, we discovered in the last 10 years that we could record these electrical signals." So the two ideas that will wend their way through my work, thinking about what he has said there, is the idea of a neuronal democracy, that is, that there is some sort of voting of the regions of the brain, and the idea of something being democratic about that way of thinking about the brain is going to be one of the themes you can watch happening in this paper. And the other is, of course, the brain is about the future and the question of the future and what signifying practices our understandings of the brain bring with them. So let me begin with a classic anthropological trope, which is to say my entrance into the field. Here, in an unnamed northeastern city, we have a map of a nondescript academic building, at the midst of which is a Siemens 3T scanner at its core in that red magnet room. The scanner magnet is a very important, intricate, expensive piece of equipment, and so it is carefully guarded. It also has its dangers, and so everybody who comes in contact with it has to be safety trained. I have been safety trained. I do not operate this thing, but I know how to be in a room with it. Basically, people come in the front door in the area called the lobby, which is in white. They move through the green area and into that yellow area, which is behind a locked door called reception. And from there on in, it's a series of locks which have to do with protecting people and the magnet itself, both. So basically, I'm talking about child neuroscience and how children are scanned in this facility. A parent and a child, or a caregiver and a child will walk into that green public area, ask for entrance through the locked door in the reception area, sit and wait until the child is separated from the adult and taken into the control room. There, the child is wanded airport style to make sure there's absolutely nothing metal on the child's person, because metal can fly across the room in tremendously destructive ways and become a projectile in a magnet. And also, if you're a little older, probably not most of the young kids, but if you have bank cards, credit cards, anything with a magnetic strip on it, so long to the magnetism. So they're very, very careful and comprehensive about this. RAs, research assistants, do the wanding. They're very, very nurturant to the children. They calm them down. They make sure they understand what's going on. In the reception room, before they go into control and the magnet, they read with the child a book called Getting Pictures with Your Brain. Brain scan pictures with an fMRI scanner, and this is what a picture of that book looks like. If I don't keep still, my brain pictures will be blurry. This is the main message here, is to get kids to lie still, or still as a mouse, as they say, over and over again. And it takes a lot of discipline for any of us, but especially a child, to stay still for long periods of time. fMRI, for those of you who have never seen one in action, is extremely noisy. It makes a lot of kind of uncontrolled, swiveling kinds of noises. It's not an easy experience, and yet children go through this regularly. So once inside the magnet room, 2 RAs fit the child with the magnet. They leave, having explained how to stay in touch through a voice connection across a mirrored wall, and they go out and start scanning the child. And the child is also watching videos in its downtime from the scanning, so they put on the videos that the child wants, and they stay in close connection. If the child is in any way panicky or restless or uncomfortable, they go right in and they take the child out of the magnet. So that's some of what's going on. When the child when the scans have been run, the child is taken out of the machine, praised, and asked to sign a receipt for payment, which varies from around $55 to $75. That is a substantial amount of money for a child, depending on the length of the study. In addition to her money, the child is given 1 or 2 printed pictures of her brain, and often these are of greatest interest. The child has completed the experiment, and the information collected in this machine, which is what the Siemens T3 looks like, will be sent uptown to the lab's office where it's continually processed. So that's the process. Later in lab meetings, some of the children's scans will be reported as failures, while others will count as partial or full successes, depending on how still the subject was able to lie and whether or not the entire length of the scanning protocol was achieved. This evaluation is linked to the continual activity of the scanning in process, where the RAs and the postdocs qualified to run the scanner talk the child through the noisy and disciplined process of lying still, eyes open, as resting state connectivity. And that's a concept I'm going to come right back to. Resting state connectivity is looked at. That is what this lab is looking at, is functional resting state connectivity, when the brain is at rest, not allegedly doing things like watching videos or doing games or having to do a recall task. This work is occasionally interrupted as a subject is repositioned or asked to lie still as a mouse so that a clearer image can be obtained. On observation days, I'll just show you this one because it chills my heart, which is a very small baby, a toddler or even younger in the brain scan. My maternal imagery is very upset by that. I am sitting with the RAs. What's in front of them is just a window that gives access to the magnet and to the child inside. I usually introduce myself to the caregivers and the children on the outside, telling them I'm not there to watch them, but to watch the scientists. Sometimes I chat with them, but mostly I sit inside. 2 preparation sessions have certified me as safety trained. That is, I could stop the magnet and get somebody out if that ever happened, although I have been told that that has never been necessary in the history of this lab, or probably most other labs. Needless to say, members of the lab team have been more than gracious in welcoming my arrival, my questions, and my observations. It doesn't hurt that I am the mother of a college-aged son who has had the diagnosis of dyslexia since the age of 6. Dyslexia is one of the conditions this lab is tracking, and many researchers are quite interested in hearing my real-life stories of interviewing other families that have a child with a diagnosis and an individual educational plan, an IEP, which is the federally mandated kind of a green card or a passport that allows you to get remedial services and accommodation, but it's also a sign of stigma, obviously, to have that kind of a labeling in your life in the first place. Imagining my son's future also transformed my anthropological curiosity, opening a window on the human brain and the negotiations now ongoing in science, medicine, education, the law, media, and amongst families concerning the reality of what movement activists increasingly label as neurodiversity, to imply a form of human difference rather than simply deficit. So that's really the story of how I got into the lab. I want to talk about how data is made in the laboratory. The data that are collected at the NII, the Neuroimaging Institute, must of course be constructed and interpreted by members of LCAN, the Laboratory for Child and Adolescent Neuroscience, that's a pseudonym, whose research I am tracking. LCAN's director and his circulating pool of high-powered international postdocs, research assistants, and doctoral students, as well as predominantly North American RAs and undergraduate interns, are well organized to investigate a series of childhood psychiatric conditions. While most famous for its studies of attention deficit hyperactivity disorder, ADHD, and its non-hyperactive variant, ADD, LCAN is also pursuing funded research on childhood conditions as diverse as dyslexia, pervasive developmental disorder, or on autism, Tourette's, and epilepsy, recruiting children with such diagnoses and comparing their brain scans with those of healthy controls, or HCs, as we say in the world of grants. Scholarly outpouring of analyses using functional magnetic resonance imaging, that is fMRI, to collect real-time images of many forms of brain activity has rapidly accelerated in the last decade as these machines have become more widespread. The work of ELCAN should be viewed in the context of the rise of neuro-everything, in the words of historian of science Fernando Vidal. Projects investigating the impact of advertising, truth and ethics in criminology, neuro responses to various kinds of music, and of course, highly biomedicalized studies of language impairment, dementia, and pathologies of personality as benign as shyness and potentially lethal as profound depression have all been subject to recent fMRI research. The eclipse of psychodynamic explanations of human variation and suffering in favor of brain-oriented, hyper-materialist explorations has been the subject of much commentary, especially in the U.S. case. This is a parenthesis, but I first aired a version of this paper in France, and France is the holdout of Lacanian psychodynamic therapy. And there they consider that our recourse to brain imaging is because we're, in some senses, hyper-materialist and lack a unified national health care system. So what we want is an explanation of a druggable target in the brain. So that would be a French explanation of what people in America are doing, although I hasten to say plenty of people are also doing fMRI studies in France as well. But it raises some interesting questions about national comparison. Among the many biomedical research foci that have been boosted into high gear by the increasing availability of fMRI technology is ADHD, the most widely diagnosed form of childhood neural impairment, estimated to affect 7 to 10% of school-aged children in the United States. Magnet research has predominantly focused on frontal regions of subjects' brains, the prefrontal cortex, the supplementary motor areas, and regions of the parietal cortex. Experimental conditions usually involve selecting tasks presumed to represent real-life demands as these areas are imaged. For example, in game playing or word and number recall, these regions are known to involve executive function, memory, and attentional focus, all initially localized in animal as well as human studies to frontal regions of the mammalian brain. So there's very good evidence for why they're looking at the front of the brain. Subjects with ADHD have been shown to have hypo, that is underactivity, and lessened cortical brain volume in these areas when compared to healthy controls. And this is presumed to account for their slower reaction time and lapses in attention while performing tasks. Yet attempts to pinpoint the actual connective neural networks that account for focal lapses, slow responsive times, and other differences of ADHD are generally regarded as having yielded weak results at best. The director of ELCAN has made a substantial intervention into neuroscientific discourse about ADHD, arguing that other areas of the brain, especially the understudied precuneus region located in the back of the brain, you see that red arrow, precuneus, back of brain, as opposed to that big sort of green superior frontal area and all that frontal stuff that follows. That's really what he and his lab are working on. So he's saying that the precuneus region located in the back of the brain is implicated in neural networks that were not previously appreciated as being directly involved in regulating attention and related phenomena. He posits that the brains of children and adults with ADHD are less able to negotiate the complex interplay between default mode network regions and frontal parietal executive control regions. I'll try to unpack that for you. Failure to suppress such default mode networks, that is the idea that there are modes of networking that are already going on across regions of the brain, that neural democracy of which Nicolaides spoke. He's saying that it's because of the way that those kind of default networks are already set up that you have these differences in ADHD and in several other conditions as well. Failure to suppress such default networks is hypothesized in his lab to affect attentional focus, causing variable response times in tasks, a well-documented sign of ADHD. Such interference can best be shown, measured, and correlated by focusing on what is deemed resting state functional connectivity, RSFC, which is based on patterns of spontaneous signals across brain regions. Subjects lie very still without task or video prompts, and scientists map and measure relationships that allow the identification of the brain's default mode network and other so-called resting state networks. Resting state functional connectivity across brain regions is presumed to represent a pre-social or an asocial map of spontaneous connection, overlooked by the more obvious focus on task-oriented brain regions, which have been the object of study in most prior research. At the present time, virtually all brain imaging hours, data analyses, conference participation, and publications of this lab are devoted to analyzing this more dispersed brain view of how children's brains actually function, that is, looking at these neural networks from different regions of the brain in resting state. We might interpret this emergent model as an instance of the neural democracy described by Miguel Nicolelis in the opening quotation. To continue his metaphor, different brain regions vote to produce various split-second differences in behavior, achieving a kind of compromise consensus across their sectoral diversity. Yet at present, the search for our resting state connectivity involving networks across multiple brain regions is in its infancy, still linked to a set of contested indicators. This is the lab director speaking. The one consistent thing about ADHD is that it's inconsistent, he said to me. Folks used to think that they could explain brain connections in the dorsal anterior cingulate cortex, that is the frontal region, a locus of attention control. But now we're showing the low amplitude waves in the precuneus or back region are anti-correlated with frontal action. They get in the way, and that's where the action is. A highly technical description of looking again at these default mode resting state networks and saying, let's shift the attention to the back of the brain instead of the front of the brain. In other words, LCAN has shifted the focus of research across regions of the brain, looking at their relations as hypothesized to interfere with task-directed actions that occur in frontal, better studied parts of the brain. Laboratory publications characterize different neurological impairments in terms of this neural democracy and its collaboration or competition across brain regions. So that's what this lab is basically doing. The presumed benefits of this research will include a more accurate description of childhood neurological differences in terms of subtle, dispersed network connectivity, and a future ability to pinpoint neural networks that may become targets of biobehavioral or pharmaceutical intervention at a future date. In the lab, the brain is thus about the future in a doubled sense. First, in those with the condition of interest, it is posited to be regionally interactive with split-second future consequences that disrupt and transform intentions in one area, derailed by subtle connectivity in another. So that's its futurity. And second, in a more obvious version of future, it is widely hoped that knowledge about such connectivity may someday provide new future possibilities for the intervention into kids who have these diagnosed conditions. As the head of a major New York psychiatry department in a public teaching hospital with a research capacity put it, quote, translational neuroscience of psychiatric illness is the future. So that's really the ground on which this lab is standing. I want to talk a little bit about how they get their research subjects and how they take the scans. The future of such translational research is built through practical and highly disciplined activity. Recruiting a research subject population is hard work. To amass adequate test subjects, both those affected with specific diagnoses and healthy controls to be matched against them, there's an intense choreography that links the scientists and their shifting army of assembled children. Youngsters are difficult subjects to recruit, as any of you who have worked with children probably know. My field notes at the lab meetings are full of outreach strategies aimed at reaching potential subjects through clinics, educational programs, after-school party programs, paid advertisements, and the ever-present Craigslist. Go try and explain in French what Craigslist is in New York City. Financial incentives are offered, but these must be modest enough to pass the IRB, the Institutional Review Board that looks at human subjects research, and still so that they're not considered coercive, while at the same time alluring enough to interest members in being part of the study. Different studies require children of diverse diagnoses and various ages, ranging, for example, from toddlers with pervasive developmental disorder to middle schoolers with dyslexia. Samples must also match for sex and handedness, two variables that have long been correlated with various cognitive diagnoses. Some children may be barred from one study but eligible for another, and a birthday or a slightly tweaked medical diagnosis may transform their situation. That kid really wanted to make money. Too bad he's too old to use as a control for our epilepsy protocol, one scanner commented. 2 months ago, that same child would have been eligible, but then he had a birthday. So this is a choreography that's always in real time and in process. The management of this ongoing and continuously recomposing subject population requires the work of a lab administrator and several RAs. It also involves cyber and geographical connections that crisscross the greater metropolitan area. ADHD kids, for example, may be drawn from local clinics and other nearby after-school programs. So too may be controls. One woman I spoke with at the lab regularly accompanied her 9-year-old granddaughter who had served as a control on many studies. The child earned $55 the day that I watched her, quite a bit of money for someone who appeared to be from a modest background as she lived in a nearby low-income housing project. Her grandmother was particularly interested in teaching her granddaughter to save, and this is the grandmother speaking. She's so proud of her pictures. She takes her brain everywhere. She's making money. It's her own money. She can do anything, well, almost anything she wants with it, but some of it has to go towards spending on college. She'll be allowed to treat herself to lunch, but really the money has to go to some good purpose. So there's a lot of social learning involved and implicated in the recruitment possibility. When I queried the staff about class differences in child enrollment, one said, quote, "We recognize that all parents want the best for their children. Unfortunately, lower class parents don't pursue this option so much." Recruiters and scanners were quite sympathetic to the diversity of children and their families, but they do not seem to be aware of recent work in social psychology, ACE, adverse childhood events, or epigenetics that suggests the profound social impact of stressful life factors to which kids growing up in poverty are much more likely to be exposed. Such contemporary research might complicate researchers' understandings of which populations of children exhibit their diagnoses of interest or how chronologies of early exposure to adversity might then affect multiple conditions and the severity of what is later diagnosed. So this is a moving target, and the question of where you move it back and forth and what they understand about the change in people's lives is an ongoing question. The laboratory staff understand that children with a relevant diagnosis are often entered into studies because some parents are interested in the result. That is, it may not be the kids so much, it may be the parents. And in fact, parents, especially in this dyslexia study, which I'll talk about in a minute, said a lot of things about it. The mother of a 4-year-old said she was really, really grateful that so many people were there as controls in the study because maybe they get to the bottom of her child's condition. And another mother said to me, "It's so interesting, why wouldn't we do this? The more you learn about the brain, what's going on with them, the brain is so interesting. It's always good to educate yourself, to know more about yourself." Despite her positive and universalizing expressions, the same mother had said while looking at her own daughter's brain scans a few minutes earlier, "It's nothing special, it just looks like every other brain." So there's a kind of hard, it's hard to reconcile the global existential expectations with the inconclusive specificity of the scans their children take home. The real story lies elsewhere from the scientist's point of view. Yet the highly experimental work of the laboratory and parent expectations in some groups with high scientific literacy and biomedical expectations may be contributing to the anticipation that studies like these will directly benefit their children and more general populations long before clinical implications are warranting. So I'm saying there's a gap between the way that parents and many other people are hopeful about what the studies will show, and that it's very hard to explain what basic research is despite people, some of whom have very high literacy. It's really, there is a kind of a gap there. This existential gap, as I call it, between parental expectations of science and the opacity of their particular child's scans will be interpreted to illustrate an ongoing conundrum. The lab staff is particularly aware of this chasm. "You should hear our phone screens," somebody said to me. "Can I take the scan to my doctor?" Parents ask me regularly. "Really?" "Sure, you can take them, but he knows less than we do." Another told me, "This is not diagnostic, but people think if you look at a part of the brain, you can say what's wrong with it. It's hard for them to understand that that is not what we're doing." One mother of 2 dyslexics who were participating in the same study expressed her frustration to the scanner. "So what can you tell me from these pictures?" "Nothing. Unfortunately, I'm not a neuroradiologist." "Okay, so I'll just go get a textbook from the library and interpret it for myself." Another mother, looking at a side view scan of her child, says, "You can tell it's him by the nose, but what's in his brain?" Again, the assumption of future abstract benefit is continually undercut by the disappointment of expectations when a scan is just a scan and does not reveal anything immediate about the child's diagnosis. At the same time, a shift across the existential gap also provides a valuable collaborative benefit for parents. A theory of neurodiversity takes the blame for a child's school or social failure off of the parents, which is to say overwhelmingly the mother. I'm scrupulous about saying parents, but I've actually only interviewed 2 fathers in a study I've done in more than 50 families, and everybody else was a mom. And maybe that's my methodology, but I also think that's what happens around school-age kids. So that's a longer discussion about gender. The materiality of brain scans potentially demonstrates a difference which is far removed from Bruno Bettelheim's classic refrigerator mother theory of autism or popular blame of ADHD on too much television, sugar consumption, or other permissive parenting behaviors, as is widely believed in the United States. If the somatic truth of a child's school problems is lodged in specific brain regions and dysfunctional connections, the materiality of the condition can be dislodged from putative parental shortcomings, enabling a parent or teacher to accept childhood differences with potentially less frustration and more compassion. The future of brain studies may thus seem comforting to some parents and their participants. Parents are not the only ones to project future efficacy into present imaging. Following LCAN members to the American Association of Child and Adolescent Psychiatry meetings in 2010, I was struck by the frequency of questions raised to poster presenters. That is, people from our lab put up a lot of posters about their fMRI research, and a lot of people came by and they said things like this. Quote, "How much will it cost to get my patient a scan showing her where in the brain her depression is?" asked one clinician. And another said, "I can see you're really zeroing in on ADHD. That's great. When will you start testing new meds?" Such questions imply that there were conclusive mapping of widespread conditions that could now be subject to what physicians imagine to be more efficacious pharmaceutical regimes. In my field notes taken during the meetings, I have scribbled down, the clinicians only want to know when the fMRI machines will be ready for diagnosis. The researchers only want to know what comes next. There's no conceptual space between tiny steps of looking at brain linkage and what the audience wants. Everything is collapsed. They want the answers now. And that's really, again, the futurity and the present tense. Lab members were unfailingly polite in answering the questions posed. But in private conversations, they were also astonished at how little practicing clinicians, often from prestigious teaching institutions, seemed to understand about the differences between exploratory basic research and translational findings. This same existential gap is regularly crossed by scan operators who interface with child subjects and their caretakers every day. Trying to understand the difference between expectation and data collection, I asked members of the lab whether they saw external differences in children diagnosed with internal differences or controls. That is, I was looking for these scientists' idea about the relation of structure of the brain to its behavioral functions, external and internal. But no matter how I framed my questions, not one member of the scanning staff ever pointed to significant direct brain-to-behavior differences beyond those of age. So somebody said to me, with the toddlers, we know they may not go to sleep, and that's the end of our scan if they squirm. An older kid, a kid with ADHD, may be very anxious or nervous. We have to calm them down, but once we get them into the scan, it's okay. And then they said, yeah, and if they're dyslexic, they may not have read the words in the storybook, taking brain pictures with your fMRI scan, and they may not be reading the subtitles in their downtime of the Simpsons video either. So those are things that help us to help them to stay still in the scan, but it's not really about what we're looking at inside. In fact, many scanners commented on how cute they found the kids to be, and one expressed amazement at their participation. Quote, "I think it's bizarre that parents let us scan their kids." I think so too. "I went into the fake scanner at the office and freaked out. It's so noisy." That is, everybody now goes through a fake scan to make sure they can take it because it is so rigorous, and they really do have to learn to lie very still for long periods of time with a lot of weird noises. Now I have a little more sympathy for the little kids who wriggle out. Yet specific diagnoses, a key element for recruitment, may be mediated through less obvious social factors that may in turn affect outcomes. A recent dyslexia study, for example, successfully recruited its subjects through the International Dyslexia Association. Most of the families who signed up through that organization were drawn from the wealthier suburbs of Westchester and Long Island. The scientist in charge, this is the reading brain business, The scientist in charge of the investigation was quite specific in her description of this population. These parents are different than lots of the parents I see from New York City. These are very strict, especially if they have dyslexia themselves or have seen it in the family. They know the value of education. If the mother's brother has it, the mom limits sugar in her son's diet, even though everybody says there's no relation between dietary intake and what actually happens to the kid. But it's considered good parenting practice. That is, they see the discipline of the parent visited on the child and the child herself becoming more disciplined. All these parents have given their children the best. They've had remediation since they were diagnosed, a tutor or a remedial reading teacher. We know the left angular gyrus is deactivated in dyslexics. It can be reactivated after intensive remediation. So many of them have had this tutoring advantage. That is, they may be reading better because they've already had these very advocate kind of services, diagnostic and then intervention services. Maybe it's already changed their reading, but not their spelling, she says, still looking for something that is going to be unremediated. Even the good readers, they have trouble with spelling, so maybe that's another set of connections. This researcher is aware of the conundrum that this raises for resting state functional connectivity studies. One could easily posit that long-term interventions have already changed neural networks before the child is enrolled. Therefore, she is suggesting that if their reading is already far from a spontaneous baseline, having been socially remediated, other aspects of their dyslexia, notably spelling, may still be amenable to differential analysis via fMRI data collection. In several conversations with me, the researcher underlined that the parents of these dyslexic kids truly knew the value of research and really wanted to participate. She had never seen such quick and reliable enrollment in any prior study in which she had participated. This was thanks to collaboration with the International Dyslexia Association. Yet the IDA should be placed in its own specific historical and social context. The world in which dyslexia was first described, interventions developed, and families later organized involves an explicitly activist context. In other words, strategies for remediation linked to science-friendly research projects already place these specific families and their potential child dyslexic research subjects in a concrete social context which may well have affected their brain patterns, which are then being tested. So you can't really abolish the social world, is really the impact of what I'm trying to say here. So let me tell you a little bit more about the data, and I'm just going to run through. If I stop, I'm terrified that I'm going to end up with not enough time. These are some blurry slides that try to show you what resting state connectivity looks like, what they're looking for in controls and non-controls. It's very hard work. That's what I keep saying about what the lab is doing. The hard work of recruitment, of getting the kids to be disciplined and lay still, of recruiting enough for a sample size. The head of this lab is an innovator and has created an international fMRI child psychiatry scan network, which goes across, by this time, I think 7 or 8 countries. And they're sharing data, they're massaging data, they're trying to figure out under what conditions the data was collected, how can you make it more comparable. So they're attempting to do all those things. Scientific collaborations have long been constructed globally as defining fields of possibilities. Now such flows are attached to brain data, smoothing out the differences across the lumpiness of laboratory life in its diverse national context. So that's some of the work of this lab as well. When scientists speak about massaging the data, let's see, right, so this is some more. I'm going to talk about ROIs or seated regions, regions of interest. This is just how they get pictures of what's connected to what in the brain. When scientists talk about massaging the data, they are referring to highly technical processes that abstract statistical patterns from images and measurements produced in the magnet, while the public, including physicians, is now accustomed to colorful images of the human brain in which various regions are dramatically pigmented to highlight working areas and connection. That is, you've seen this on the front of Newsweek and Time, as well as on my slides. These bear little relation to snapshots of an actual individual brain in one particular moment in time. These images are brilliantly hued composites of data compiled to emphasize the direction and density of connections that researchers have painstakingly correlated in the human brain. Let me talk a little bit technically about what they actually do here. I'm just going to throw a bunch of vocabulary words up on the screen, and I will explain them as we go. The lab uses, basically at the present moment, it's using at least 2 major programs. It uses more sometimes for other studies, but these 2 are the main ones. The first is that the magnet collects data using blood oxygen level dependence, that is BOLD, fMRI scans, which track direction and density of blood flow, hemodynamism, through regions of interest, ROIs, in the brain to identify potential functional networks of connectivity. Although the signals are small and only measured relative to one another, highly sophisticated statistical formulae can be applied to lift the data out of the background. That's important, signal to noise. They really work with it to make sure, if we seed it this much, if we do this region, if we do that region, if we both do them together, how are we going to make the data kind of lift themselves out of what's really a lot of chaos and very big data driven? So it is, as the much bemourned late anthropologist Bill Roseberry said, our data are made, but they are not made up, right? And that's really what these kinds of negotiations are about. They also use DTI, or diffusion tensor imaging, a complementary and newer technology using water diffusion to measure connectivity in the brain's white matter in the regions of interest. White matter is the name given to the nerve fibers or axons deep inside the brain which carry messages across the regions. Thus, the convoluted, asymmetrical, three-dimensional space of the brain can be smoothed out using these two techniques and described as a map. The mathematics involved are highly abstract, and in the written version of this, I won't bore you with it. I go into explaining what a voxel is, which is a three-dimensional pixel, and how you choose the spacing. It's like graph paper, but in 3 dimensions and across, a really messy terrain. How are you going to choose where you take your scan images, and then how are you going to correlate them and look at relative difference in the flow of either hemodynamism or the way that the white matter is actually lined up so you get the structure of the brain. By comparing the relative strength and direction of these signals, the signal-to-noise ratio, neuroscientists search for associations between brain regions that are neurally networked. Quote, getting decent data, that's what it's all about. We started an algorithm to get functional resting state connectivity reconstructed. It leads to better SNR, signal-to-noise ratio, as one lab scientist said to me. I mean, nobody who wasn't highly trained could understand what exactly he's talking about. His data are highly abstract, provisional, and negotiated, yet they are considered exciting, too, and that's very important. This is cutting-edge research. But they exist in an expert space far removed from the public imagination of brain imaging, abstracted from standardized measurements that are intended to smooth out and make comparable very subtle differences in energy flows amongst brain regions, which may correlate with aspects of diagnostic behavioral differences. Such images are highly experimental. Thus, the status of what is real in brain imaging is constantly under statistically expert construction. And there's, again, a profound existential gap, I would argue, between neuroscientists' daily experimental processes and what many other publics, including many clinicians, parents of affected children, and young adults living with these diagnoses, anticipate. Nonetheless, brain imaging has entered the collectively produced future imaginary. And so I want to turn for a minute to the public work that brain imaging does out of the lab. Brains regularly float out of the laboratory. They are tethered in the narratives parents tell about their children's diagnoses and struggles. When I asked parents of children who carried a school-related diagnosis to describe their child's brain, the hybrid notions they produced were quite complex. Often their children's brains were metaphorized through other pieces of contemporary technology, as these interview excerpts demonstrate. For example, I'm talking here about a mother whose 7-year-old had just been re-diagnosed, adding pediatric bipolar disorder to his prior category of Tourette's. She described his brain this way. This is her quote. It's all messed up. It's very complex. I imagine it's like a crowded desktop of a computer. You can't find any files in there, although they're all there. He's a mess. He's always in trouble at school. His brain doesn't work like the other kids. His brain is just different. Likewise, an adult acquaintance of mine who was only diagnosed with ADHD after his own children received this label and its medication regime said to me, I'm also HDTV, just like the kids. I only discovered that as an adult. It explains a lot. There's attentional stuff all over my family. Years ago, they didn't go for this. I just figured out what to do to get through school. I was always with the slow, dumb kids. My brain just didn't work. It didn't help. Learning music saved my life. And contemporary electronics provided his humorous metaphor of HDTV for ADHD. These individuals' use of high-tech metaphors also resonates with an ongoing public debate about whether early exposure to such platforms transforms the brain through multitasking and other behavioral adaptations that may encourage ADHD and what I here take to be neuronal democracy. The most reflexive, self-reflexive interview I conducted took place with a medical student, Rajid, who grew up between India and United States. He had recently been diagnosed with both learning disabilities and ADHD. Having spent his life in a high-achieving educational familial context figuring out ingenious private strategies for his own accommodation in isolation, without support. As our interview began, he pointed out to, his Sony voice recorder to me, and he said, "This is pretty much my second brain." So again, that use of the electronics to explain that what's going to come up in the kind of scientific understanding of the brain. Becoming a brain scientist was a goal that enabled him to think more deeply about his own brain differences and deficits, searching for biomedical explanations and intervention on behalf of himself and of many others. And this is his interview. He says, "ADHD, you know, it's very controversial. Dyslexia, it's a little bit easier for people to swallow. There's a neurological, I use that word neurological instead of psychiatric. That's a neurological kind of thing. Can we completely change your brain? No, we probably can't. But I can find out what makes my weaknesses, and then I can turn them into my strengths. That is precisely what makes me, what will make us great. And that's what's going to be the thing that gives me great confidence." So that use of the idea that difference could become part of something positive, not only something negative, is, I am arguing, part of the neuronal democracy that's kind of seeping out of this way of thinking about the brain. Many mothers likewise adopted the language of neurology and neuroscience to justify their own perceptions of a child's worth, despite school struggles and stigmas. As one mother put it in describing her daughter's school-based gaps, things just go into her brain and happens in a completely different way. And she's got some really, really strong talents and abilities that a lot of people don't have because of this way her brain is wired. But there's no question that she has trouble reading. You know, it's a processing thing. You know, it's the way her brain processes information. It's very different. And she can come across as not very bright. And then when they see what she can do, they're always saying, "Oh, she's so smart." These mothers and others are describing their children as cerebral subjects. That's a term I take from Daniel Ortega. Such brain-centered explanations appropriate the concept of neurodiversity from social movements predominantly mounted by young adults diagnosed with autism. That is, neurodiversity itself is one of those terms that was staged by the Autism Self-Help Network. They may offer comfort to those who struggle with various forms of childhood difference. Let me see how I'm doing for time here. Some populations seem particularly open to brain deficit explanations. There's a whole section in this paper I'm going to skip here about adoption, because there is a kind of folk knowledge in the adoption community that a high percentage of kids have ADHD or learning disabilities. And I won't tell you about my long goose chase to try to figure out where they get their numbers, but they say, many adoptive parents will say, oh, 25% of kids who are adopted internationally have these problems. But there's no basis that I could figure out. I mean, maybe somebody else knows, but it's not that easy to figure out what our adoption records look like and link them to diagnoses in the state. So I have some very interesting interviews in which they describe why they think this could be the case with an adopted child. And I also have interviews with parents who reject that notion, who basically say, as did one mother of an adopted child, look, Carlos is charming and very socially connected and very, very lazy. It's just in his character not to work too hard in school. He doesn't want to be singled out with labels, and they never did him much good anyway. That is, he had an IEP and he just didn't follow it. So I just have to stay on him to get the homework done. And an African-American professional mother rejected the diagnosis of ADHD given her daughter, who changed schools 3 times before she was 8 in search of what her parents viewed as an appropriate acceptance. And the mother says, a child this ebullient who can't sit still is at grave risk of being labeled and medicated. The black community is very conservative about children's behavior. They just want her to suppress all those impulses. And in the predominantly white schools, everyone is looking for her to be a role model. It's not a fair demand to make on a child who is a little slower to pick up her social cues. In this mother's view, a child under social pressure was being over-medicalized by what I might label as brain blame here. Some mothers remain agnostic about their children's brains, and here's a mixed metaphor between sort of brain and kinship that one mother produced for me out in Queens. Maureen McNamara, obviously a pseudonym, offered a mixed kinship diagnostic explanation of blended inheritance when I asked her about her children with his 3 kids, one with autism on the spectrum and another one in the process of getting diagnosed at the time I did this interview on the autism spectrum as well. And she says, I do think the rise in autism from the children being diagnosed better. Back in the day, I think that if you were high functioning like Asperger's, you were like speech and language delayed or language delayed. I think if you were low functioning, you were mentally retarded. And now I think they're getting it better. I don't know where it comes from, and I certainly don't know if it has anything to do with the brain. According to my daughter, that's the oldest of 3 children, I'll tell you what she told me when Gregory, that's the one with the unambiguous, if anything is unambiguous about this stuff, autism diagnosis. I'll tell you what she said when Gregory was diagnosed. She was 9. She informed me one night that it was her fault, that her brother was autistic. And I says, why is it your fault that your brother's autistic? And she says, because when I was in your belly, I took all the smarts, and I didn't leave anything for Greggy. I said, well, if you took all the smarts and Greggy got what was left, she said, yeah, I know, she interrupted me. I don't know what's going to be left for Kevin, who was on the process of getting a diagnosis. So that's a very interesting family story. These are not the only people who are using this brain as diversity, brain and science as part of their daily life. This hybrid usage of brain as diversity is particularly apparent in the words of young adults who succeeded in getting through their public school years with the benefits and burdens of IEPs or special education labels. My fieldwork includes participant observation with Project Eye to Eye, the first national organization by and for young adults who grew up with diagnoses of ADHD and LD and also had IEPs. Having gone to college against considerable odds, they now are organizing chapters across the country. When I started this research, they had 27 chapters. They now got a big grant to go up to 60 chapters. They're somewhere in 30 numbers of chapters. This is a cresting movement of young adults who were themselves diagnosed and are now in college. College-age participants in Project Eye to Eye provide a beyond normal art class. Their official publicity. As an after-school activity. They go into the local middle schools in areas around them, and they work with kids to do art projects, kind of like art therapy, but their point is to get kids to be confident about their diagnoses, to use their accommodations, to own their difference, to tell them that it's great to have a differently abled brain, not that it's a problem. So they are doing that work. When you go to their organizing institute, which I've done, you get a T-shirt, and the year that I went, it said, "Organizing a revolution one classroom at a time." So that's kind of what they're doing. They're in various schools, and I follow the NYU chapter as it goes into a local middle school to see what's happening. My interview with NYU's chapter head began with her announcement, quote, "My brain is raging today, and I don't want to take the meds." She told me her story of continual re-diagnosis as dyslexic and dysgraphic in a New England town, and the discouraging educational experiences that had circuitously brought her to leadership in Project Eye to Eye. Now, after diagnosis with ADHD on top of her prior learning label, she continues her story. You can look at it and say there's compensation. That's how my brain, its plasticity works, and that's the science stuff. Where do we take the information that we learn about people with different kinds of minds? And all this science stuff comes out as, well, autism is a good thing, and ADHD is a good thing, and all these sorts of childhood disorders that end up being so well researched, they're all good things. We get funding thrown into them. In this very fast-paced world, you have to be able to set yourself apart. You have to be able to think differently. And so what does that say? For people who've been able to think differently their entire lives and haven't put themselves in a little box, what are we going to do with this information? This young woman is raising activist aspirations and doubts about what I have here labeled neuronal democracy. That is, what can she do with her difference? That is accepting that it's a brain difference. It is worth noting that her ideas about the importance of accepting the potential creativity of differently abled brains are an instance of how scientific thinking diffuses far beyond the laboratory findings noted at research centers like LCAN. In appropriating the idea of neuronal democracy, I point to the cultural distance between her social valorization of putative brain differences and how this concept was used to describe specific research finding by neuroscientists investigating momentary processes of brain action in Miguel Nicoleles' radio interview, which opens this talk. The effects of laboratory research and the metaphors used to describe them may serve unintended and expansive purposes in the practices of those who see their subjectivity embedded in research findings. So they're expropriating the work that's going on in science in general and using it in these other much more activist fashions. Dave Flink and Marcus Sustris, respectively the Executive Director and National Program Director of Project Eye to Eye, expressed similar sentiments of one of my earliest interviews with them, and this is Dave speaking. We're forced into labels. We need to embrace them. Say, I am dyslexic. Cognitive diversity is just the same as saying I'm black or I'm tall. It's just another physical thing. When your label remains invisible, you're in the closet. You can't do your best. Your brain works better when you've got the accommodations you need. Listen to the mixing of the social movements in that quote. It's very rich and very labeled. Coming out as being different, having a different brain, and using your accommodations to succeed is central to the mission of Project Adhd. In the new NYU chapter to which I serve as mentor, 3 students with 3 different diagnoses expressed similarly the importance of understanding neurodiversity. As one said, "It's a way to get excited about being different. Now I know that my brain just works differently. I pay attention to everything that can be turned into a good thing." They too are embracing a theory of neuronal democracy. The summer that I attended the Organizing Institute, which is held every year in Providence at Brown University, which is where Project Adhd started, they have when I was there were about 45 people present. There now are about 90 kids who have a diagnosis who are brought in from colleges that range from extremely elite institutions like Brown and Columbia have chapters to community colleges in Montana and California and Arizona. I mean, they're all over the place. Wherever there is somebody who wants to be an activist and organize a chapter, Project Adhd will try to fly out and get the financial support and work with them to try to organize a chapter. It's absolutely fascinating. But you're really inside of LD ADHD chapter when you go to visit the Organizing Institute. It is like entering another space. And while I was there, Dave, the president, the CEO of the organization, was surrounded by activists cracking special ed brain jokes. He was talking and they said, "Pitch it quick, I've got a short attention span," called one. And another said, "Don't ramble off message, my brain can't follow," quipped another. After a workshop that participants were asked to evaluate, they were always evaluating their own workshops, Marcus Sustras, the national program director, said, "I promise this is the last survey all you dyslexics will have to figure out." And within a nanosecond, some wisecrack immediately yelled out, "Do I get time and a half for this one?" So they really know how to play the game in terms of the language involved here. As a participant observer, I was often struck by the habitus, the physicality of what they were doing together in their social movement. There are posted breaks for where you can go stair climbing. There are squeeze toys for people who have problems sitting still. At one point, I was taking notes in a very large gym, and I was asked to move to the back of the gym because the tapping noise on my computer was disruptive to some people with ADHD. This population embraces meds and their potential side effects. They talk about it all. They embrace neurodiversity and its biomedical and educational accommodations as a potential strategy for building their personal and political futures, and they do see this as a political movement. They are not alone. Paul Yellen, a neurodevelopmental pediatrician at NYU's Langone School of Medicine and founder of the Yellen Center for Mind, Brain, and Education, pushes this idea of disability as diversity to its limits. "I think everybody is potentially learning disabled," he says. "It depends on what you're trying to learn. I also think that nobody's learning disabled. I think that we have this huge false dichotomy that we have typical learners and learning disabled, and I think it's really damaging." In these parental, professional, and young adult discourses, the materiality of brain differences underlying diagnoses and remediation is embraced as the positive wave of the future. Let me put on, I think we got one more picture. It's just more pretty pictures of Project Adhd working with kids. In these excerpts from their annual Organizing Institute, where new national chapters are formed and chapter leaders are trained, national leaders Dave Flink and Marcus Sustras articulate a theory of differently abled brains and the role of neurodiversity in building a future without prejudice toward cognitive disabilities and the people who carry them. Here's a portion of Dave's opening speech at the conference. It's quite moving. "I came here today from the future. I ripped through the space-time continuum to tell you something. I'm going to tell you about the future. I saw some awesome things. Disabilities don't exist in the future. Why? Because LDs don't have the same meaning as they do for us. Because they don't affect us anymore. 30 years in the future, we've created an environment so inclusive that our spelling, our inability to pay attention doesn't matter. 20, 30 years ago, they called us mentally defective, retarded, lazy. You need to work harder, sit still, they'd say to us. About 30 years ago, a bunch of people quit hiding their disability. They just quit. I get distracted easily. These kids you'll be working with are the future. You're holding the torch to the future. We're going to change their world. We're going to the future with this. We put the labels on and people will follow. We teach these kids that their brains are a resource, not a problem." So it's a very upbeat kind of oratory, motivational speech that he's really giving to these people who will be the future leaders of their campus chapters, working with kids in the local middle schools. All right, by way of conclusion, let me say something. The neuroscientists whose research opened this essay share with Project Adhd this profound construct. The brain in all its neurodiversity is about the future. As Miguel Nicolelli so appealingly put it, neuronal democracy provides a contemporary metaphor for a future plus que parfait. There's a French remnant left in this paper. Yet there is also a profound existential gap separating the quotidian extrapolations of small amplitude frequencies as abstractions on the part of pediatric neuroscientists, that is, this very technical, small work that they're doing, from the widely perceived public reception and indeed constitution of neurodiversity as a helpful context in medicine, disability activism, and family life. The various constituencies whose words and practices I have sketched here are not necessarily seeing the same burdens and benefits of putative brain differences, and they don't see them from the same perspective. Nevertheless, collectively, the human brain is rapidly being hailed as a bridge to the future by neuroscientists, clinicians, families of disabled children, and activist young adults characterized with ADHD and LD themselves. In their company, we presently peer over an existential gap. There, neurodiversity is increasingly engaged as a polysemic metaphor for the acceptance of human difference lodged in the physiological brain, concretely in the brain. Neurodiversity, as I have tried to show, is under intense negotiation not only in labs, but also in households across America, where 15% of school-aged children are now diagnosed for special education services. Some of them will grow up to be activists like members of Project Adhd. Whatever future is negotiated across this existential gap, we are all stakeholders in the status of its reality. Thank you. I've talked to you a very long time. Please, comments, questions, she says, looking at wires and looking for a microphone. Yeah.
Listening to your characterization of neuronal differences, I get this impression of something that might be incredibly static and durative and unchanging, whereas another part of the narrative seems to embrace this notion of brain plasticity.
Yes.
Experiences can actually alter at
Right.
any level of observation kind of brain differences.
Right.
And I think in that comes a whole new set of affordances and extrapolations. And
I think people in the field are struggling with exactly that, and some of the easiest ways to deal with it are the idea of pharmaceuticals, right? That is that you can go from something static to a change, but by doing this intervention. But you're raising, as I am trying to raise, some of the much larger social issues about, in a way, if public health has known that that poverty is very, very bad for the health of children, their mental health as well as their physical health, that would be the place of change.
When you talk about brain dynamics, I think it comes in the cultural context of this assumption that, wow, there's something very static and durative that we've discovered about this population or this brain, and I think the entire culture just jumps to that assumption automatically, and I think it's really important to frame this in a way that brings in the possibility of brain plasticity and changes.
Absolutely, and certainly any good neuroscience researcher knows that and understands that, and that's been part of what's been so exciting in this field over the last, 15, 20 years, really. So I think you're absolutely right. Yeah. Other comments here? Hi.
So I was interested in this gap that you talked about. I was really intrigued by, when the researchers are presenting their poster and these people are like, hey, when's the cure coming around the corner? And so I'm just trying to kind of get you to weigh in on this a little bit more. Does this gap come entirely from people who are ignorant about it, or is the research itself, does it have to call upon these promises in order to keep this funded? So I'm wondering how, even though the researchers kind of mocked clinicians for seeing these curative benefits, if they themselves, I would assume, kind of talk, even though there's this huge gap, they in fact kind of presume.
It's a really good question. We were sort of talking about that in the psychiatry department today. That is, when you write a grant, you're under pressure to say this is the next new thing and we're going to solve this problem. Because if you're not going to solve it in the 18 months of your grant, then why should they fund you? But in fact, anybody who's working in a lab knows how slow and indirect research progress really is. I mean, we're all just little cogs in the research wheel. I do think that you can get both parts of it if you want to know that, but what they are really saying in those examples is that practicing clinicians really they're really driven by the idea that this stuff is ready for intervention, and it's very far from that. I don't think it's ignorance exactly, but I think it's that combination of the hype, which is part of the funding structure, which is part of, getting your brain image on whatever, Time magazine, which is part of the idea that you're always manufacturing something in the culture that's the next new thing. And at the same time, no matter how careful the neuroscientists are, there's also a great desire. There's some really fabulous popular writing by neuroscientists, who are trying to explain this to the rest of the population. And sometimes they get it exactly right and say, it's not ready for primetime intervention, but it is teaching us all these amazing things about the complexity and the openness, the plasticity, as you said, of the human brain, especially children's brains. But a lot of times they get stuck in exactly what I'm calling that gap. I think it's a hard place, and we're in the middle of realigning how you go over that gap at the present moment. Yeah, David.
In the breast cancer literature, there's an increasing number of studies about the corporatization of the movement, the pharmaceutical industry moving and kind of capturing and transforming it. Are you seeing any evidence for that with this movement?
That's a great question. I haven't seen it, but they certainly, Project Adhd, people certainly use a business model. They think of themselves as a nonprofit. They definitely network with business. They are not funded by pharmaceuticals as of yet, but you may be pointing the way to something that might happen 5 or 10 years down the pike. It's not out of the question. It's very interesting. Right now, they are funded a lot by small family foundations, people who themselves had dyslexia or have a kid with ADHD or whatever. I think it's a very classic American process by which families who have some resources turn them over to the study of somebody who they're intimately acquainted with to trying to find an answer. And I think that's what's done a lot of their funding over the last, they were funded in '97. They got started, so it's not that long. But I think you're pointing towards something important, because that's certainly what happened in the breast cancer movement. So.
About the metaphor of democracy and the possibility that that's part of what gives that traction is a particular kind of visuality that's going on here, right? Because democracy is supposed to be evocative of equality and social cooperation, which is where I think the voting bit comes in. But we're not talking about EEG. Right. We're not talking about other ways of measuring things that are going on with the brain. We're talking about this presumed picture, right? And I think, especially in the slides that you had and you see in popular culture everywhere, where it's the mother even said it, right? It's the same brain like everybody else.
Right, exactly. Right? What's the big deal? What am I supposed to get from this?
To be some kind of social construction of how brains work, particularly within that lens of it's a democracy or it's about the future or about voting about the future or fixing the future, is really, really important to talk about that in terms of this particular moment in visual culture too, right?
That's very, very helpful what you're saying. I think the visuality of the thing is absolutely critical. This is one tiny piece of a large, sprawling, totally undisciplined study that I've been on since 2007. We figured we officially started with my friend Faye Ginsberg, with whom I often write, who is the queen of culture and media at NYU. And actually most of our writing, not my stuff when I do science, technology, or medicine, but most of our collaborative writing is exactly about the visuality of this stuff. And what I would say is that you've got to look at the visuality of inclusion. And some of that democracy is about inclusion. And that goes back to a lot of social transformations, to just tick them off. Deinstitutionalization in the 70s, NICU and the salvaging of low birth weight babies, many of whom grow up with mild cognitive impairment. IVF meets the children of the poor in the NICU, because IVF babies now are diagnosed at something like 25% of them will have mild cognitive impairments. At the same time, the rise of IDEA, which entitles every child in America to a free, appropriate education, public education. Civil rights, and the way that the disability movement rose in part on the inspiration of the civil rights movement and then adapted it for their own meaning. So the question of democracy is literally in the law. It's literally in the structure of deinstitutionalization, the idea that those kids are going to grow up with their families and their communities, which means that there's a huge, again, another existential gap between what it is to experience your child and how you access any of those so-called democratic services.
Well, and if I can just follow up, I think that's why, Project Adhd
Yeah.
Right? Visuality, hello. And
Exactly.
if we're talking
Exactly.
about inclusion, the difference between representations of democratic and educational inclusion that have people with cognitive disabilities versus physical disabilities, right? So everybody's brain looks the same on the inside, but as a culture, we have a hard time looking at people with
Oh
physical.
yeah, the mind-body split stuff goes back. I
Yeah.
mean, you could argue to the Greeks, but certainly in our century, it's very, very difficult. And the disability rights movement, disability studies have been all over that question like crazy. So I think you're absolutely right. And you've got to think of the visuality as part of democracy in a much larger sense of what inclusion is legally, as well as socially, ethically, politically, yada, yada. It's a long, complicated road. Yeah. Elizabeth.
You know, in the disability field, there's a pecking order
Yes.
of disabilities
Yes.
and a hierarchy of which disabilities are cool and okay to
Yeah.
study and which are continually stigmatized. But I found it interesting in your talk that people with severe intellectual disabilities or moderate levels of intellectual disabilities, not ADHD, LD,
Right. These-
mild
right.
impairments, Asperger's, high-functioning autism, weren't a part of your
Right,
equation.
exactly. And in fact, Project Adhd would say we are not equipped to do that. We're about LD and ADHD. And, you know, we were talking in psychiatry this afternoon, I think my friend has already left, so about what do we think the future is going to look like? And my best guess would be that the ADHD, LD kids are going to be the most successfully integrated, that there's already a kind of a cultural comfort. A lot of ADHD jokes, don't be so ADHD, somebody will say to somebody else, you know, when they forget something. I think those are the kinds of disabilities that will be integrated as a kind of diversity model of democracy and inclusion. And I do think that the hardcore issue of cognitive difference and what counts as deficit, all of that is so much more complicated. But again, if we look at the larger project, like some of what we've been doing is going through different forms of media activism and the representation of people with much more difficult to accommodate disabilities as they turn up in public culture. So I just saw this amazing film about a kid with Down syndrome who wants a girlfriend, and you know, how he deals. Yeah.
But you might be interested in learning about People First, which is
Yes,
a
yes.
network of self-advocacy individuals that
Absolutely.
moderate levels of intellectual disability and
Right.
advocacy efforts as well.
Right. Thank you. Yeah.
I was sort of taken with the quote that you read about the sort of metaphor of coming out of the closet.
Yeah. Yeah.
And if you think about LGBTQ movements and their history and sort of the varying degree with which these sort of learning differences movements and LGBTQ movements have been comfortable with biological explanations as a source of the difference.
Yeah.
It seems that they're kind of going in divergent ways right now. And also incidentally, you know, they've both been movements where at various times people have blamed mothers.
Right. Mothers get a lot of blame whatever you do.
Right. So just sort of wondering why you think that is, that there's a really stark contrast in how we're comfortable with explaining difference. You know.
That's a really interesting question, and I must say I have not thought that through. To me, it was just a layered quote about pulling on different social movements, but I'm going to go back and make your point. I should get your name and credit you for it, and talk to the Project Adhd people about it, because it is a very different way of thinking about biology and biological reductionism and all the rest of it. So I don't know. I mean, there was a period even within the sort of sexual difference movement where there was a time when at least it was entertained that there really might be some biological differences, but that research was so discredited and so badly done, and there was so much feeling that it was just another way of re-stigmatizing a difference that it was really, really rejected. So, but we are definitely in a biological moment. Maybe we've been there for a long time, and we're certainly still moving in that direction in general in the culture. So it's a very interesting problem you're raising, and I wish I had an answer. Any other thoughts about it? You want to say something? And then I haven't forgotten you. I saw that hand. All right. Is it related or something else? Okay, let me get to you first, and then we'll come back to you.
What I was going to mention is that you used one term specifically, differently abled, and what that brought to my mind was some research I had read that looked at dyslexia and found that there might actually be increased increased enhanced peripheral vision, which is terrible for reading, but could be very helpful for
Right,
other tasks.
right.
So what I'm kind of asking about is the idea of not only thinking differently, but actual cognitive enhancement,
Right.
and how that plays a role in, parents and doctors who are trying to get you that idea.
That research was just in, I want to say 2 Sundays ago, the Sunday Review at the New York Times. I'm not quite sure that I've got the reference right, but talking about it's called The Upside of Dyslexia, and they do a popular journalistic version of exactly what you're talking about the peripheral vision and the way in which they might be better scientists for certain kinds of things. There was an outpouring in the letters column then from people who saying, never mind that this stuff is good, it's so hard for my kid to get through school, or this is not recognized. Even you might be right, but it's not recognized in the way that services are offered. So people were sort of saying, and I'm not saying that these letters are representative of anything, who knows what those 5 letters really are, but sort of saying, hold on a minute, there are steps between here and there in which we might valorize the difference and talk about just, rather than disability, a difference, but we also have to recognize how hard it is to get these kids the accommodations they need to succeed in life. So, yeah.
So, like the person behind me, I was particularly intrigued by your phrase, the existential gap. And you posited kind of the focus on data collection on the researchers, and then the thirst for new interventions on the patient and their parents. I'm curious whether it's not simpler an epistemological gap rather than existential gap. So you could say spirituality and religion is about existential problems, but it could simply be an epistemological
Right, that
problem.
these are different systems of
That
understanding.
we are asking the wrong questions and hoping to find answers using approaches that ultimately will not address the problem. I'm not going to argue Lacan here, but
Right. Understood.
If that's the case, if we are really mixing metaphors here, that studying brains gets us somewhere, but it does not address these issues of diversity, for example.
Yeah.
How do we resolve that? Because these are existential problems, but in fact they will not be solved as existential problems. They could be solved, however, through education and as an epistemological.
Well, needless to say, I don't have the answer, right? I mean, that's exactly right. It's a huge, big question. But I guess what I am arguing is that they're not just parallel worlds, but that they're totally interactive worlds, despite the best efforts by the research scientists, who are often very, very sympathetic to the kids they're working with. But they may think that they can sort of say very carefully, this is exactly what expert knowledge provides. This is the epistemological moment of what we can know and what we can't know about the brain, period, end of story. But it doesn't stop the continuous translation process.
I was intrigued, you as an anthropologist saw these 2 different groups of people, on both sides of the glass wall.
Yeah.
And you saw the researchers salivating over the data.
Yeah.
And then you saw the patients and their parents, and it seems that they were living in completely different universes. So do you think they're actually coming together?
Well, I don't think they're so completely different in the way that I tried to show that what it takes to recruit the kids, what the parents' hopes and fears are. You're absolutely right that you could say one is epistemologically much more precise than the other, rather than just putting them together in the gap. But I do think the gap is continuous, and it continues to move us toward a certain kind of a future, which will be an extremely materialist future. I mean, maybe the brain will disappear and be less in vogue in 20 years. I don't know. When I started doing my work, I'm old as the hills on this. Every day there was something about the genes and genetics, and then there was the genome, and that was all over the place. That's not, in popular culture at nearly the same rate that it was maybe 15 years ago. It's taken for granted. It's become a technology. It's simply in the lab, and people simply take it as given. And it's in a very different place in terms of popular culture than it was, say, 10, 15 years ago. So we'll see. That's an open question, right?
Great. Well, I'd like to first invite everyone to a reception right after this, and thank Professor Rapp so very much.
Thank you very much. They were great comments and questions. Thank you.